So let's talk about how to find the integral, in other words, the area under the curve, but with your graphical display calculator, so your GDC. I like this, doing calculus, isn't it great? We'll use integration to find the area under the curve, and we'll do it for definite integrals, which means now we're going to know exactly where to start and where to finish. So maybe I have some sort of graph that goes like this, let's just pretend. And maybe I want to find out the area under the curve from here, let's just say, to maybe here. Whoops, need to make a nicer straight line. It should look semi-straight at least. Let's say I start off at A and I finish at B. And I'm curious, what is the area under the curve from here? So what is this area here? My calculator is going to help me with this. So here we're going to do it with a calculator. There we go, like this. There we go, so I've shaded. This is what I'm trying to do here. I'm going to attempt to do this integral of, let's say this here is called f of x here. I'll do the integral of f of x dx. I'm going to do it from A to B. That's how I'm going to write it here. Okay, I'm going to write it in this way. In fact, let's go ahead and do that. So this is how we define the definite integral. We do a definite integral when we know the bounds. We know where we're starting and we know where we're finishing. So we don't have to add this plus c business when we didn't know what to do. So on your formula booklet, you actually get this equation here. You get that the area between a curve, which is y equals f of x, and the x-axis, where f of x is greater than 0. Basically, they're just saying, just like this, where the function is above the x-axis. What's this area here? That's really what they're telling you. So how do we do it? Well, we just write down the equation that they give us, which is just the integral here from A to B. Now they call it, instead of calling it f of x, they called it y. So they say y dx. And that's it. I mean, isn't this actually kind of easy? This is the equation here. There we go. We get this right here. Whoops. This here's your formula booklet, so that's on there. Let me maybe label a few things here. So this means basically start here. Maybe I'll write it like that. I'll say start here, end here. That's what we mean here. End here. So here's your equation. This is your function. Okay, so this is your equation you're using. And again, just to show you what this is, we have some sort of curve. Maybe it does, I don't know, maybe something like this. Let's just pretend. And we're going from A to B. So whatever A is, I don't know, maybe A is here. Maybe B is here. We're finding this area right here. That's what we're finding. Okay, we're going to find this area right here. That's A. That's that A is that area here. So we're going to find that area. A nice little pro tip is that when you're doing something on an exam, always write out the integral, even if you're going to use your calculator. You need to write out the whole integral. Don't forget the dx business. And there you go. Well, we can do this on our calculator quite easily. We can do it in a couple ways. One is by graphing. So I'll show you that way. So on the TI Inspire and the 84, well, all of them actually can do it this way. I'm just showing you how to do them with the 2 TI ones at least. Let's see how to do this. First things first, we're going to graph it. Then we're going to find the integral. Okay, so that's how we're going to do it. We're going to first graph it, then we're going to ask our calculator for the integral. We'll type in the upper and lower bounds, and away we go. We can also do it directly, so we can do it without doing the graph. We can just ask our calculator, hey, give me the integral from here to here. Here's what I do. So it depends on if you use fn_int, if you're on the TI-84, TI-Inspire. Here we go. Let's see if we can do this practically here. So got this example here. We're going to find the area between f of x and the x-axis of x squared. Now let me first just try to sketch it just to give an idea what it looks like. This one at least is not so complicated. I have a pretty good idea what this one looks like. All right, so let's just say it goes like this. And I'm going to say this is x, this is y, and I can even sketch it because I know what x squared looks like. This is x squared. It goes like this, something like that. I mean, it's not exact, but something like this. I want to go from 0 to 1. I even know that. So right here, this might be 1 here, and this point right here will be at 1. And I want this area right here from 0 to 1. I want this area right here. Okay, from 0 to 1. Well, how do I find that area? You first need to write down your integral. So I'm going to say the area, A, I can say, is equal to the integral from where do I start? Well, I start at 0. Where do I finish? I stop at 1. and I write down the equation. So it's going to be x squared dx. I'm going to do this on my calculator. I'm going to ask my calculator for this answer. So let me show you the two ways to do it. One is by doing it with a graph. So I'll just graph this function. I'm going to graph x squared. There. Now I'm going to do menu, and I'm going to go to analyze, and I'm going to say, give me the integral. Do you see that one right there? It says, where do you want to start? So instead of clicking somewhere, I just type in the answer. I just type in 0 for the lower bound. Upper bound is going to be 1. There you go. So from 0 to 1, the answer is 0.333. Do you see that? So that means the answer is approximately 0.333. Well, there we go. Now, if you ask your calculator for this, of course, it'll tell you that's 1/3. But at least this is the answer here. It's approximately equal to 0.333. Isn't that kind of nice? Now, your calculator can actually, do some of those things for you, but I mean, yeah, I think it's actually a pretty neat way to do it. Let's do another example. So we'll do this one right here with f of x equals x squared minus x. Oh, by the way, sorry, I didn't show you how to do it directly on your calculator. So what if I wanted to do it without doing the graph? I have to go directly on a calculator here. I just press menu, I go to calculus, and I say do a numerical derivative, do a numerical integral. So look, it's got the symbols for me. Start at 0, go to 1, give me the equation right here, which is x squared, and don't forget, do it dx. That's just in case you had multi-variables going on. And look. Now, if you want to convert this right here, you can always, you can do lots of things here. You can do numbers. You can convert this to a fraction if you wanted. I mean, that's kind of nice, and you can say, it's 1/3. But there you go. So you got the answer. Let's do another one. Let's do this example right here with x squared minus x. We'll do the area under the curve. We'll see if we can draw it here. So I'm going to just attempt to draw this one. Here's my first thing here. Here's my axes like this right here. I'm going to draw my x and my y. I'm going to do it by graphing. I like that way. I think somehow graphing just makes me feel happy to see what the graph looks like. So I'm going to do a graph of x squared minus x. Okay, well, that looks like this. Do you notice? Something like this. So, I don't know. I didn't draw it perfectly, I'm sure, but something like, something like that. Whoops, that was a really bad drawing, but something like that, I guess. So this will be x squared minus x. Now I'm doing it from, let's see here, from 2 to 3. So from 2 to 3 here. So there to there. So something like, we'll just say that's 2, we'll say that's 3 here. It doesn't have to be perfect, but something like this. I'm going to go from 2 to 3. I just like to see what I'm actually doing here. So here's what I'm attempting to find the area of. So how do I do that? Well, the area will be equal to, we've got to write it out. So it's the integral of x squared minus x. Don't forget the dx. I'll put in brackets maybe. And I know where to start. Start at 2, finish at 3. So I'll do this directly on my calculator here. I'll say menu, I'll say analyze, I'll say give me the integral. Where do I start? Remember, I start at 2, so I just type in 2, enter. Upper bound, 3, enter. So from 2 to 3, do you notice the answer is 3.83, I guess I could say. That's approximately equal to. So I'll say that. So I'll say it's approximately equal to 3.83. Maybe I should write a little bit nicer. So 3.83. This is my answer, and I'm done. Isn't that kind of easy? So your calculator can do this for you. And like I said, you could have done it directly. Just to show you how to do it directly, I can open up a new calculator page and say menu and say give me some calculus. I want to do numerical integral. So we'll do it this way. I'll say start off at 2. I go up to 3. My function is x squared minus x. And don't forget dx. Go. You see I got the answer there? So this here is how I can do this in a couple of ways, right? Directly or with a graph. Either way, I get the same answer, don't I? Ta-da!